All right, this is just a question from the assessment, and so I was asked to share a video maybe to try and explain it a little bit better. And so here's our situation. We want to be able to withdraw $40,000 from our account each year for 30 years after you retire. Now we expect to retire in 25 years. We found an account that earns 10% interest, so we need to figure out how much we're going to need to deposit every year until retirement in order to have that goal, which was to withdraw $40,000 a year. So here's the situation. Here I am today, and I am going to retire in 25 years. So 25 years are going to pass. And during that 25 years, it looks like I am depositing some money every year. So we don't know how much that we are depositing. We just know we're going to do that for 25 years. So for this part right here, what we're really talking about is a savings annuity. The savings annuity formula that we have is PN is equal to D times 1 plus R over K to the NK minus 1 all over R over K. Okay, so that's our savings annuity. But again, we don't know how much we're depositing. We do know a little bit more. We know that it's earning 10% interest. And so for the next part, or actually the beginning, it says that what our goal is to be able to withdraw $40,000 each year. And just looking back one more time, when we said deposit, it was also each year. So that's starting to give us already what our K value is, which is each year, that's annually, that's one time a year. So once we hit like this point right here in our life where we're going to retire for the next, let's say 30 years, we want to be able to withdraw $40,000 each year. So for this portion, what we're talking about is that payout annuity formula. So our payout annuity formula says that P naught is equal to D times 1, oops, undo that, 1 minus 1 plus R over K to the negative NK all over R over K. So basically, if you look at the savings annuity formula, we want to figure out how much to deposit, and then this is going to be like what amount of money that we have. We are missing both those pieces of information for the first part, pre-retirement. So the reason why we're missing that is because what we need to do first is actually calculate what withdrawing $40,000 every year requires us to have in our little pot of money. Because that's really what's happening, is that we're depositing money for 25 years to make like this pot of money that we can then withdraw from for the next 30 years. Okay, so P naught is the thing we do not know. We know that we're going to deposit $40,000 every year. And our interest rate is 10%. We're going to write that as 0.10 over K, so that's going to be that 1. And then negative NK, we're doing this for 30 years of our retirement. So it's 30 times 1, so we can just write 30 on there, close that off. And this is all over 0.10 over 1. So for our Desmos calculator, we're going to enter that information. So it's really one big fraction, so I'm going to start by pushing the A over B button. And I know that the amount of money that I want to withdraw is 40,000, right? So we had 40,000, 1, 2, 3, make sure I put enough zeros on there. And then we have 1 minus parentheses 1 plus 0.10 over 1. Going to arrow over to close that off. And then I need to put an exponent on that. So I'm going to push the A to the power B button. And it's going to be negative. We were doing this for a total of 30 years. So 30 times 1. And then we're dividing that by 0.10 over 1. And so it looks like the amount of money that we need to have in there is going to be 377,076.58. And so that's what we need to have in that like pot of money when we retire if our goal is to have $40,000 every year. So then what we want to do is say, okay, so how much do we have to save? So in our savings annuity, that's pre-retirement, we want to be able to have that amount of money. And so we want to figure out what our deposits need to be. So we're going to put that 377,076.58 in place of that PN. Is equal to D, which is what we want to solve for. We're going to have 1 plus our rate, 0.10 still. So all of that is still the same. Our years change, though, because we're only going to be able to retire in 25 years. So this is only going to be able to compound for 25 years. We'll do 25 times 1. And this is minus 1. Close that big parenthesis all over 0.10 over 1. So then we're going to have to plug that into our decimals calculator, but notice that what we want to find is this payment amount, D. So this whole entire piece over here needs to go away. So there's a few different ways to make that go away. To me, the easiest thing is just to divide by that. So what we're going to enter into our calculator is that 3, let's see. So it'll be 3. How will this work here? Doesn't like my app here. Hold on one sec. Let's see, 377,076.58. And we're going to divide by, I'm going to push the divided by button. And I'm dividing by like that entire chunk that was next to D. So I'm going to write it in as a fraction down below that. And it has a parenthesis, 1 plus 0.10 over 1. And that's a closed parenthesis. And our exponent on that is 25 times 1, so it'll just be 25. And then we're going to arrow over, minus 1. And then our denominator of that is 0.10 over 1. And so it looks like annually we're going to have to deposit $3,834.14. And so this amount of money, if we deposit it, if this is deposited for the 25 years, it would create the pot of money, that 377,076.58. And with that pot of money, this would allow, after I retire, to have $40,000 every year.